All right, this video is going to go over 6.2a polynomials. Basically, a polynomial is just an expression with a bunch of terms. So you can have it either standard or factored form. Standard form looks like this. It is not factored. And factored form would look like this. All right, so keep that in mind. Now, one thing you really care about is the degree. So in standard form, you go with the highest exponent. So here's what I mean by that. Look at number 1. 2x cubed comes first, but that's not the highest exponent. The highest exponent would be this minus x to the 6. So this would make it degree 6. Look at the second one. The highest exponent is that x to the 8. So that would make it degree 8. And then this one, there's not even an x. So that is degree 0. Now look at factored form. In factored form, you want to add the exponents. So like, there's going to be some that don't have an exponent. When that happens, they get a 1. So like this one, to add these little exponents here, it'd be 1 plus 2 plus 2, which is 5. So this one's degree 5. And then look at this next one. I've got a 2 here. This one doesn't have an exponent, so I'm going to give it a 1. So, and then a 3 at the end. So this one's 2 plus 1 plus 3, which is 6. All right, now, when you deal with polynomials in standard form, it's good practice to write them in descending order of exponent. So you want to find the guy with the highest exponent first. Make sure you attach that negative sign with it. Don't just call it positive x to the 6. And you write these things in decreasing order of exponent. So here's what I mean. You would have f of x equals. The highest exponent is that negative x6. The next highest would be that plus 2x cubed. After that, it would be that plus 7x squared. And then after that, the minus 4. And when it's not factored, this is in standard form, you go with the highest exponent, which is 6. Look at this next one. They want it in descending order. So the first one would be that plus 8x5. That's the highest exponent. So this one, I would go f of x equals 8x to the 5th. And then the next one's that minus 3x to the 4th. So minus 3x to the 4th. The next one is this minus x squared. Then comes the minus 4x. And then comes that plus 9. And this one's not factored either. So you go with the highest exponent, which is to the power of 5. So it's degree 5. All right, moving right along. All right, if it's degree 1, it's just a linear function. If it's degree 2, it's a quadratic. If it's degree 3, it's a cubic. If it's degree 4, it's a quartic. Now, odd even degree is really, really important. Basically, if it's an odd number, it's an odd degree. If it's an even number, it's an even degree. So this first one would be an odd. Second one would be even. The third one would be odd. And the last one would be even. The sign of the leading coefficient, positive or negative. That's basically going to tell you how the arrows at the end of your function should be. So like you're going to have these functions, right? Well, they're going to have arrows on the end. You can tell where those arrows should be based on your leading coefficient and the degree. So here's what I mean. If on an odd function, the leading coefficient is positive, it's going to look like this. If it was negative, it's going to look like this. On an even function, if it's positive, it's going to look like this. And if it's negative, it's going to look like this. On a cubic, if it's positive, it's going to look like this. And if it's negative, it's going to look like this. And on a quartic, if it's positive, it's going to look like this. And if it's negative, it's going to look like this. Basically, you can think of it like this. If you have a positive odd function, your arrows are going to go like this. If you have a negative odd function, let me do that in a different color. If you have a negative odd function, it's going to look like this. If you have a positive even function, they're both going to be going up. And if you have a negative even function, they're going to both be going down. So this is so important to know. All right, so when they talk about end behavior, yeah, you can do it like as x approaches this, y approaches what. But really, I'm just caring about these arrows right now. So like on a linear function, if it was a positive, it would be a down-up arrow. If it was negative, it would be an up-down arrow. On a quadratic, if it was positive, they would both be going up. And if it was negative, they'd both be going down. On a cubic positive, it's going to be a down-up. And on cubic negative, it's going to be an up-down. And then on a quartic positive, it's an up-up. And on a quartic negative, it's a down-down. I know that kind of sounds like a lot, but really just memorize this right here. This is so important. All right, now in terms of degree, leading coefficient, and behavior, here's how you do this. This is in factored form, meaning I have to add up my exponents. So this guy gets a 1, remember. This is degree 3. And LC stands for leading coefficient. That's the number right out in front, okay? So this is a negative leading coefficient, -3. Maybe I should draw a little arrow right here. All right, so what that means is this is a cubic function with a negative leading coefficient. So if you look back at this chart we just made, it would be referring to this right here. So that means these arrows on a odd degree with a negative leading coefficient right here, odd, negative, it's an up-down. So my end behavior here would be up-down. Okay, let's look at another. This is in factored form, so you need to add up all these exponents. So this x gets a 1, and then this parentheses gets a 1, which makes this degree 4. My leading coefficient is a 2. That's positive. So this is an even function with a positive leading coefficient. It's a positive even. Positive even is an up-up in behavior. Okay, let's look at another. This is in factored form. I need to give everything its exponent and add them up. So this is degree 3. My leading coefficient is a positive 2. So this is a positive odd function. Positive odd function goes down up for its end behavior. So that's how I did those. Again, this is so important. If you don't know that, you're probably going to fail your polynomial quiz or test. So just saying. All right. Given the polynomial graph, state if the degree is odd, even, and if the leading coefficient is positive or negative. So look at this one. The arrow goes up, up. The only way my arrows can go up, up is if it's a positive even. So it has to be an even degree, and my leading coefficient has to be positive. All right, look at the next one. It is an up, down. The only one that goes up, down is a negative odd function. So this is an odd degree with a negative leading coefficient. The next one is a down, down. The only one that does down, down is a negative even function. So my degree has to be even. My leading coefficient has to be negative. And then this last one is a down, up. The only one that does down, up is a positive odd function. So my degree is odd and my leading coefficient has to be positive. So we'll dive way more into polynomials, like how to graph them and all sorts of other stuff in the next couple videos, but this was just kind of an intro. Again, if you don't know this kind of table that I made over here, you're not going to do well on this. So maybe go study that and it'll help you to get all this stuff. All right. Hope this video helped.